Hello guys, this is the review of the weekly assignment. Alright, let's get started here. So, first, we have this expression and we want to find out the dy over dx. As you can see, we have to use the product rule here. So first we're going to be taking the derivative of x squared, which is 2x times e to the dx, plus taking the derivative of e to the dx, which will be e to the dx itself, and then x squared. So as you can see here, this will be our answer. But when we factor out the common factor, we end up getting e to the x with x in front of it. Then we end up getting 2 plus x. So anything equivalent to this one would have been our answer. Seems like choice C to be the answer. Alright, number 2. Domain. When you look into the domain, the denominator cannot equal to 0. And this x squared minus 4 has to be greater than 0, or greater than or equal to. Rather. Now, the fact that the one that includes this one will be either this one or this. And when you look into this one, the fact that x squared has to be greater than 4, that means x will be equal to 4. X squared will be equal to 4 when, if I have to use the number line, negative 2 and then 2. But since the in this case, when the values of x is less than negative 2 or greater than 2, then we realize that those will be equal to, those will be greater than 4, hence this will be satisfied. Meaning, right here. How did I know that? One simple way for you to do it is if you have to sketch x squared minus 4, then we would have had a parabola that goes this way. See, above the x-axis would have been positive, and below the x-axis would have been negative, as you can see, if this one was to be the x-axis. So therefore, we are looking at this section, but of course, which one gets us this inequality? This portion. This only account for the upper right side of the expression. So our correct answer will be choice D. Alright, let's look at number 3. Velocity is given by e of t and then moves on a straight line. How far does the particle move from here to here? Then all we have to do is integral from 0 to 2 d of t dt, which will be equal to integral from 0 to 2 of the expression e to the t dt, which will be equal to e to the t, with antiderivative of e to the t is e to the t itself, from 0 to 2. Now then this becomes e to the 2 minus e to the 0. But e to the 0 we realize e squared minus 1. So therefore our final answer will be choice A. Alright, now the graph here is concave down for all values of x such that, meaning we are looking for negative concavity. So let's try to find the derivative. So here, y, if you assume y equals negative 5, and then x minus 2 to the negative 1 power, by taking the first derivative, we get to realize it becomes 5 times x minus 2 to the negative 2 power. But here you will realize that by the chain rule, we just have to multiply by 1. So it doesn't really matter. Y double derivative becomes negative 10 and x minus 2 to the negative 3 power. In other words, we have negative 10 over x minus 2 to the third power. Now, and in this case, yes, the second derivative will never be equal to 0, but one thing that we get to realize is when x equals 2, this will not be defined. So we can, in fact, using the number line with the value of 2, proving the somewhat, similar to critical point. Then what we end up getting is this. We have, when x is greater than 2, what do we end up getting? then denominator becomes positive, and while the whole fraction becomes negative, so this becomes negative. On the other hand, if the values of x is less than 2, we will get positive. So negative concave down, that means we are looking at this portion. So x has to be greater than 2. Choice E. Alright, let's look into this one. How are we going to find the derivative of this? Now, if you wanted to use the quotient rule, the bottom one will be squared. And the numerator becomes derivative of the top, which is 1 over x, times the denominator, which is x minus 1 over x, ln of x, times the derivative of the bottom, which will be equal to 1. So here, when we simplify this one, we get 1 minus ln of x over x squared. That's basically what we end up here. Seems like choice D to be the answer. Alright, the next one. Here we have, in fact, you have to use the u substitution. So let u equals 3x squared plus 5. And we get to realize du is equal to 6x dx. But as you can see, we only have x dx right over here. We don't have 6. So what we're going to do is we're going to divide each side by 6. Which gets x dx can be replaced with du over 6 right over here. Then this expression now can be rewritten as du over 6 with the square root of u. Now, if I have to rewrite this one, I can bring 1/6 out of the integral for simplicity sake, and then this becomes u to the negative 1/2 du. Now, by adding 1 and then divided by the fraction, divided by the exponent, what we end up getting is you have 1 over 6 times u to the 1/2 power over 1/2 plus c. Now, let's bring this one down over here. And what we end up getting is 1 over 3, 6 times 1/2. And u, in fact, is equal to this expression. So we have 3x squared plus 5, the 1/2 power, plus c. So it seems like we have these two possible, 1/3, and this one. Choice D becomes our answer. Alright, let us move on continually. Number 8. Now here we have second derivative is negative. What does that mean? Then we are looking at negative concavity. In my case, I like to look at the second derivative first because it gives us easier choice to consider the first derivative. Since the first derivative is positive, we are looking at portion that's increasing. That means we are looking at this. Anything goes up in this way, which seems to be B to C. Choice 2. Choice 2 alone, which is B becomes our answer. Alright, next. Here, this is what we have, and then dy over dx. Let's try to find the derivative of this one. Here becomes 1. Plus, using the product rule, we have 2 times x dy over dx plus 2 times y, and dx over dx becomes 1, minus 2y, and then dy over dx equals to 0. Now, when you plug in 1 for each nx and y value, then what we end up getting is this 1 plus 2 dy over dx plus 2 minus 2 dy over dx equal to 0. Interestingly, what we end up getting is this. This cancels out with this one, which leaves us with 3 is equal to 0. Well, we know that that's not possible. So therefore, our answer will be non-existent. The derivative doesn't exist, which allows us to have this kind of condition. Alright, So here, so what are we going to do? We have to take the antiderivative. Then here what we end up getting is this. Since k is a constant, what we end up getting is k x squared minus x to the third power over 3, which goes from 0 to the k. Now, if you have to plug in k, here we end up getting k to the third power minus k to the third power over 3. If you have to plug in 0, what we end up getting is this. We get 0. But this one must be equal to 18. So this simplifies into 2/3 k to the third power is equal to 18. And k to the third power, in fact, becomes 27, which allows us to have k is equal to 3. Then our answer is choice C. Alright, so here we have the equation of the line tangent to this curve. So we do have point already, so all we need is the slope. Slope, how are we going to get it? Find the derivative from here. So here it goes. F prime is equal to x times the derivative of 1 minus 2, x to the third power becomes 3 times 1 minus 2, x to the second power times by derivative of inside, which is negative 2, plus 1 minus 2, x to the third power. And derivative of x becomes simply 1. And once you plug in 1 comma negative 1, in this case you can only put 1 in place of x's. What we end up getting is this f prime, the slope, now becomes 3 times 1 minus 2 square times negative 2, and then becomes minus negative 1 to the third power is simply negative 1. Then here, if I have to simplify this one further, this becomes 1. So we have negative 6 minus 1 becomes negative 7. That's the slope. Only thing that has negative 7 would have been this one. And once you plug in 1 comma negative 1, it would have also make sense too. Alright, let us move on to number 12. What is the derivative of sine? It becomes cosine. But the angle is pi over 3. So we end up getting cosine of pi over 3 becomes 1/2. Alright. Continuous and have the derivative in this way. Now, then what is this equal to? By the fundamental theorem of calculus, you're going to take the antiderivative of this one. Then we end up getting f of c minus f of 0. That's how we would have gotten the integral, but the function has a continuous derivative on, then yeah, I guess this becomes our answer, which is choice A. Alright, here, what are we going to do? Taking the derivative, so this becomes 2x to the 1/2 power. So what we end up getting is f prime must be equal to 1/2 comes out, 2x to the negative 1/2 power times by derivative of inside, which is 2. And these 2 cancels out with 1/2, simply leaves us 1 over square root of 2x. And once you plug in 2, what we end up getting is that must be equal to 1 over 2. Choice B. The particle moves along the x-axis, given by in this way. For what value of t? Particle at rest. At rest basically means velocity has to be equal to 0. So here velocity is equal to 3 t squared minus 6t minus 9. Then, so when we set this one equal to 0, that means we can divide whole thing by 3. We end up getting t squared minus 2t minus 3 is equal to 0. Then t, when we factor minus 3 times t plus 1 has to be equal to 0. That means t must be -1 over 3. But t has to be greater than 0, so therefore -1 cancels out. 3 only. Choice C becomes our answer. Alright, how are we going to do this? One way which we can do is that we can use the U substitution, or we can expand it. In my case, why don't I just expand it for now? And we end up getting 9x squared and minus 12x plus 4 dx. And what we end up getting is 3x cubed and then minus 6x squared plus 4 from 0 to the 1. When it's 1, we're just going to add up the coefficients, which ends up being 1. When it becomes 0, minus becomes simply 4. So what we end up getting is negative. Just 1 second. Yes, I made a silly mistake here. When you plug in 0, antiderivative of 4 becomes 4x. So therefore, when we plug in 0, it becomes 0. So our answer is simply 1. Choice D becomes our answer. Alright, number 18. In this case, we have to take the derivative twice. So let us try to take the derivative first. Y prime is equal to -2 sine of x over 2 times the derivative of inside, which is 1/2. And 2 cancels out with 1/2, we end up getting negative sine of x over 2. Then when I take the second derivative, we end up getting negative cosine of x over 2, but multiplied by its chain rule, derivative of inside, we end up getting 1/2. So therefore our final answer is -1 over 2 times cosine of x over 2. Alright, it seems to be the E has to be our answer. Alright, let's move on. Here, what are we going to do? If you set U, since the numerator has 1 degree smaller, that means the numerator can be derivative. So set U equals to x squared plus 1, then du becomes 2x dx. Notice we only have x dx present. That means 2 has to disappear. That means dividing whole thing by 2. Then x dx can be replaced with du over 2. And that expression now turns into, I'm going to leave the intervals, I'm not going to write out the intervals because I'm going to go back to x. And interval actually has to be changed when we change the variable from x to u. Then we end up getting du over 2, and then this one is simply u, which will be equal to 1/2. 1 over u, u. When you take the antiderivative of that, we end up getting 1/2 ln of u plus c. Or in fact, we're just going to get some sort of interval. And what we end up getting is 1/2 ln of u becomes x squared plus 1 for the values of 2 to 3. So once we plug in 3, then we end up getting 1/2 ln of 10 minus 1/2. When you plug in 2, we end up getting ln of 5. And if you have to simplify this one further, 1/2 is common. Then ln of 10 minus ln of 5. And what we end up getting is ln of 10 over 2. Subtraction between the logarithm is division of the numbers. So we end up getting 1/2 5 right here, 5. ln of 2. That's what we end up getting. Choice B. Alright, let us move on. Let f be the polynomial function with degree greater than 2. Okay. So then cubic or more, and happen to be two values of x, get you 1 as y, then which of the following must be true between a and b? The fact that they have the same y value, that means there must be, coming back like this, that means there must be one point where slope is equal to 0. So therefore, choice 2 would have been correct. This is modified mean value theorem. So therefore 2 alone. Alright, so with this, we're going to stop for the first part, and then we will continue with the second part of the review video later. Have a nice day. Bye-bye.